Let's talk about unit circles. So first of all, we want to talk about the p-norm of a vector. So let's let v be a vector and p be a positive number that's greater than or equal to 1. We can allow p to be a positive number that's between 0 and 1, and the calculations give results, but they don't correspond to a distance. And so for a distance, we need p to be at least 1. So the p-norm is given by the absolute value of each of the components raised to the p power, add those all together, and raise the result to the 1 over p power. So when p equals 1, this corresponds to the Manhattan or taxicab distance. We have just the absolute value of each of the components. And so in, say, for example, the two-dimensional case, this corresponds to distance being the absolute value of the horizontal component plus the absolute value of the vertical component, which then matches the idea of traveling on city streets that are laid out in a grid. And so the taxicab distance would be how many blocks did you travel in the horizontal direction plus how many blocks did you travel in the vertical direction. So east, west, and north, south, or again, if the streets are laid out in a different direction, but still on a horizontal grid. So p equals 1 is a reasonable way to measure distance in certain situations if you have to stay on a rectangular grid. When we look at p equals 2, this corresponds to the standard Euclidean distance. Square all the pieces, add them all together, and then raise to the 1 over p power, which means take the square root. When p is infinity, we can't actually put in the value p equals infinity, so this involves determining a limit as p approaches infinity. And it turns out that in this case, we get the absolute value of the largest component. So to think about a unit circle, recall that a unit circle has radius 1, and we're going to consider unit circles that are centered at the origin. And so for p equals 2, we get the unit circle we're used to. And in this case, notice that the circle intersects the axes at the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So all 4 of those points are on the circle. And the circle, again, has radius 1. If you measure from the center, every point on the circle has a distance of 1 away from the origin. So what happens when we look at the p-norm when p is equal to 1 when we look at a unit circle? Again, we want a unit circle centered at the origin. And in this case, the unit circle looks like this. From the center to a point, these are all distance of 1 away, because again, we have to calculate distance just in a vertical or horizontal direction, so that's the same. But for instance, if we look at the point 1/2, 1/2, that distance is 1/2 unit to the right and 1/2 unit up, and so that point is also 1 unit away. If we went over 1/4 and up 3/4, again, the ideal all the way around. And so in this case, a unit circle looks like a square that is turned 45 degrees relative to the axes. And again, the same points are on the circle at the corners of the square in this case. So with the unit circle, we think about the value of pi, pi being the ratio of the circumference to the diameter. And so what happens here? What is pi in a one norm environment? Well, let's think about how long this side happens to be. From one end of this side to the other end of this side, we have to move over 1 and up 1, so this side has length 2. We go all the way around the circle. There are 4 sides of length 2, and so with 4 sides of length 2, the total circumference is 8, and the diameter is 1, 2. So in this case, pi has a value of 4. So the same idea of measuring distance in terms of this taxicab thing, taxicab metric, gives us a different value for what pi would be. Now again, it's specific to this way of measuring distance. So if we were one norm people, if everything we did was grid based, we wouldn't imagine that pi was anything else other than 4 if we even cared about pi. We would think of it in this way of the ratio of the circumference to the diameter, and the value would be 4 in that case. So let's consider the unit circle for p equals infinity. Again, we want a unit circle centered at the origin. And so when we look at the unit circle centered at the origin, it turns out to be a square again, but this time those 4 points that we talk about, 1, 0, 0, 1, negative 1, 0, and 0, negative 1 are still on the circle. Again, using circle in the context of what it would be in this case. But every point is a distance of 1 away from the center. So for example, the point up here at negative 1, 1, its distance from the center is the largest absolute value. So from negative 1, 1 to the origin, the largest absolute value is 1, so that distance at the upper corner is 1. But the distance at the point on the left is also 1. The distance to the point in the bottom left-hand corner is also 1. Any point on that line is 1. All the way around, this square corresponds to the unit circle. So as we said, once again, the same 4 points are there, but arranged in a different way. And so the question now is, what would pi be in this case? So if we think about the same definition in terms of the circumference divided by the diameter, we need to think about how long each side is. So how far is it, say, from one corner to another corner? So from this corner to this corner, we've traveled from negative 1, 1 to 1, 1. And if we think of a vector there, we have traveled a distance of the x value is 2 and the y value is 0. And so this side has length 2. And again, all the way around, the side is length 2. So the circumference is 8. The diameter is 2. And so in this situation, again, pi turns out to once again be 4. unlike the situation when p equals 2 for the value of pi that we're used to. So what happens by changing the way we measure things, it changes not just distances, but it changes a lot of things. So trigonometry would be different if we were one norm or infinity norm people rather than typically thinking in terms of the regular Euclidean distance, the 2 norm. Turns out that unit circles for different values of p, we've seen the situation for p equals 1 that's here in purple. P equals 2 is the blue circle. P equals infinity is the red square around the outside, and other values of P kind of fill in between. If we do the calculation with P equals 1/2, again, there are other issues with distance, but roughly you would get a shape for a unit circle something along those lines that's inside. And as p gets smaller and smaller and closer to 0, it becomes more and more concave. So what happens? Unit circles are different depending on how we measure distance. Pi becomes different depending on how we measure distance. We don't usually think about pi in those other scenarios, but if we did, then the value would be different because the way we calculate distance determines much more than just specifically the distance, but everything else becomes related to that as well. So once again, if you have any questions, look me up on Discord or send an email and let me know what you think.